Good day, future engineers. I'm Engineer Darwin Tacobanza, and today we will talk about a calculator technique that you can use in solving engineering problems. In the era of advanced engineering mathematics, Fourier transform deals with decomposing a function of time, for example, an electric signal, into its corresponding frequencies that make it up. This is the same way on how a musical chord or tune can be expressed as the amplitude or loudness of its constituent notes. In a given problem, we will use a calculator technique on how to solve a Fourier transform of a function. Allow me to read the problem. Find the Fourier transform of the given function of time is equal to e raised to negative 3 absolute value of t. Fourier transform is defined as function of omega is equal to function of time multiplied by e raised to negative I omega t, derivative of t, with the limits of negative infinity to the positive infinity, or the integral of this product. The expression e raised to negative I omega t is what you call the kernel function. Let's take a look on the choices given. If you already know the direct transformation of this given function, exponential function of e negative 3t, you can simply solve this easily. But allow me to teach you about this calculator technique. The expression or the kernel function e raised to negative I omega t integration using the calculator is not possible due to the presence of the imaginary number. So to address this, we need the definition of e in terms of complex numbers. So let's take a look on this transformation. So the kernel function can be substituted with the functions cosine and sine. So the formula will be function of omega is equal to the integral of function of time replaced by cosine omega t minus I sine omega t, derivative of time, from the limits of negative infinity to the positive infinity. Since the imaginary number is just a coefficient of sine function, this can be factored out. After factoring out, we can further proceed in the integration or using calculator to compute for its value. In this calculator technique, we can set the following parameters. Integral of the function of time for the given, which is e raised to negative 3 the variable t will be replaced by x, cosine of 0.5 x from the limits of 0 to 25. The calculator will evaluate this, and let's store this in a variable a. Next is b. In our memory b, that will be the value of function of time multiplied by sine. So let's do that as well in our calculator. Function of time e raised to negative 3x times of sine 0.5 x from 0 to 25. That will be the value of the imaginary part. Now, our only concern here is the real part, which is the cosine, which has a cosine function. Now, you will notice our function here is an absolute value. We all know that the graph of an absolute value is an inverted V or a V shape. This will give us a hint that our value in stored A, let's recall this, A should be the twice the value of our given. So the new value here is this 0.6486. Let's store this as our new A. So this is to reconcile the absolute value portion. Now the next step or the last step on our calculator technique, since we have the real part considered, is to evaluate the given choices with our omega. The omega set as parameter as 0.5. So if we have option A as our first example, that is negative 3 times omega, which is 0.5, to plus 9. So the purpose of this is to compare our stored value in the following choices. The answer here is this, which is not equal with our stored value. Let's try option B. Option B is if you will notice, the variable A has the same value with option B. So in conclusion, this is now our final answer. So to review, we can use calculator techniques to find the Fourier transform of a given time function or a function in a series or time series. As long as we remember that the definition of a Fourier transform is this integral expression. Thank you for listening, future engineers. I hope you learned something about a calculator technique that you can use in solving engineering problems. See you on the next video.